Sometimes it is impossible to choose the right thing. There are big uncertainties in a judge's life. Imagine you are the judge and say there is a suspect, allegedly a murderer, but there is some evidence pointing the other way. You must decide whether he is innocent or he should go to the chair. A or B. No third option. This video is about how to choose the right option. Let's take two human girls, Lucy and Katie. They are both healthy in any way, and none of them has super hearing abilities or anything. So both should get the same score on a hearing test, right? But humans are weird, man. To the same sound intensity, Lucy gives positive and Katie gives negative. So why can't they both hear them? They are the same animals. We will solve this problem with the signal detection approach. We start the experiment by telling Lucy and Katie that we will present some sound, and if they hear, they have to say yes. Lucy thinks and decides that she wants to be sure she doesn't miss any sound. Maybe because she wants to prove that she has a good ear or something. Because she tends to say yes, we will call her liberal. Katie doesn't feel the same.
Even in the wizarding world, hearing voices isn't a good sign.
Maybe she saw Hermione say that and she grew up to be a conservative responder. Even though they have the same ears and brains, sensitivity-wise, they have different characters. So, Lucy gives yes responses more than Katie. This graph may tell she has a better hearing for now, but it will change. At this intensity, for example, Lucy is more likely to report that she hears. There is a thing called Criterion. Lucy has a low Criterion because she says yes to the slightest chance, whereas Katie has a high Criterion. After all, she says no to most things. But why these girls can't be sure? It is just a sound, and they have exactly the same level of hearing abilities. It wouldn't be so hard without noise. Okay, the stimulus is called the signal, right? A tone, a light, anything. Everything else is noise. They interfere, confuse the person, and they are inevitable. Even when you are in a soundproof room where there are no sounds whatsoever, you would be distracted by your own heartbeat. On any trial, the noise will randomly increase or decrease the signal intensity, and because the signals we are dealing with are very faint, noises can be mistaken for the signals. They lead to false alarms. Let's make a chart of all possible outcomes. There might be a stimulus or not, a signal or just a noise. And the participant has two options to choose from, yes or no. When there is a signal and participant says, yes, I hear, it would be a hit. When there is no signal but she says, yes, I hear, it would be a false alarm. When there is no stimulus and the participant says, no, can't hear, it will be a correct rejection. Lastly, the participant might miss by saying, no, can't hear, even though there is a stimulus. Two true and two wrong answers. This one is called type 1 and this one is called type 2 error. Let's go back to this man. He might be a murderer or not. He can't be both. And you may decide whether he is a murderer or not. There is no third option. In a type 1 error, if you say he is a murderer but he is innocent, you could execute an innocent man. In a type 2 error, if you say he is not a murderer but he is guilty, you could set a murderer free. Good job! In the experiment, we present the signal 100 times with different intensities and we give noise 100 times in random order. Lucy, as a liberal, reaches 90 hits out of 100 and just 10 misses. But with no stimuli trials, the noise ones, she gives 40 false alarms and 60 correct rejections. Katie, however, reaches only 60 hits and 40 misses, only 10 false alarms and 90 correct rejections. While Lucy is more successful on hits and Katie has more successful on correct rejections, is because of their criterions, because they have different characters. But how do we prove that? We change their criterions by manipulating them with money. This is called payoffs. We declare that each hit will win $100 and the correct rejection is just $10. Katie, who doesn't like saying yes too much, suddenly changes her behavior. She becomes more liberal and gives 98 hits and only 10 correct rejections. I mean, you would do the same thing, come on. We do the opposite payoff to Lucy. Give $10 to hit but $100 to correct rejection. Now she becomes a conservative. How very odd. But the interesting thing here is that their ROC curve or receiver operating characteristic curve is falling on the same curve. They changed their behavior perfectly proportionally. So this means they were equally sensitive to the tones at the beginning. Their mindset was different, not their thresholds. But why do we care whether these girls hear a tone or not? It is all about giving the correct decision. Imagine you are a radar operator and you must decide if it is a flock of birds or a plane on your radar. A miss might lead a catastrophe. This is a probability distribution. Noise refers to the flock of birds or an innocent man. Signal plus noise, because there is always a noise, is the plane or the murderer hiding between innocent people. If a sound has a clear 30 loudness, it is easy to tell it is a signal. If it is a 10, easy to tell there is no signal. But this is where the devil lies. Remember what was the difference between Lucy and Katie? Criterion. When you see a criterion at some level, everything that falls to the right of it is perceived as a signal, and everything on the left is noise. It is your threshold, and you are to wherever to put it. If you set your criterion rather lefty, you would make a lot of false alarms as a liberal, but you will hit more signals. If you set it to a rather right side than usual, you will have fewer false alarms, but you will have more misses. All of this we have talked is used for measuring a system's sensitivity. This ambiguous part between the two peaks is called D prime. If D prime is small, the system's noise and signal distributions would be so close and the system would not be so sensitive or safe. If you can design it to have a bigger D prime, you can achieve high sensitivity and you can have fewer misses or fewer false alarms. So that's how we interpret these graphics. Thanks for watching and I'll see you around.